When we are given a relation represented by input-output pairs, how can we tell whether it is a function or it is not a function? There are three very simple rules we can use to judge that if it is a function or not. The first one is one-to-one relation. If the given relation is one-to-one, that means if you send in one x, you will get one y out. Different x's got sent in, then different y's will come out. Like this example here shows you, sending -2, you get 5 out. 4 goes in, 0 comes out. 8 goes in, 12 comes out. 13 goes in, 18 comes out. So different input, we get a different output. That is a function relation. This second rule is a many-to-one relation. That means you send different input into that machine, you might get the same output. That is still a function. Like this example here, you send 1 into it, you get 4 out. But you send 2 into it, you also get 4 out. Like this example, you have 2 different input. Input 1 and input 2 both got sent into this box, but you have just one output come out. That is still a function. This kind of many-to-one relation, in real life, you can think of a juice maker. You can send in different kind of fruit into that juice maker. You will always get juice out. So that is a functioning machine. So we say many-to-one, this kind of relation is a function. This third one says one-to-many. This relation is not a function. Why? That means you send in same x into that machine, but you will get a different y to come out. Like this picture shows, you send 1 in, you will get 4 out, and you send 1 in again, you will get 5 out. That's not a functioning machine. You can also see it from this example. The left side represents different people. The right side is for different cities. It's the city they were born. Now, if it's a many-to-one relation, it could be all these 3 people are born in Dallas. That is okay. But look at this example. Ben was born in Dallas, and also Ben was born in New York. We know that's not right. So one-to-many is not a function. Keeping those rules in your mind. Now we can see some more examples on this chart. We have talked about this before. These are the 4 ways we can use to represent our functions. How can we tell whether it is a function or not from each different representation? Simply speaking, we are looking for repeated x. That means If you see repeated x, you are sending same x into that box several times. But if you get different output, different y's come out, then that is not a function. Look at this first example. This is a set of points. We have 3 points here. You see this x is 1, and this x is also 1. 1 is repeated. But for this one, we have 2 come out. For this one, we have 3 come out. So we know this is not a function. Look at the second example. This is a table. Same thing. We are looking for repeated x. We see we have -1 repeated. We are sending -1 into it 2 times. First time we send -1 in, we get 4 out. Then we send -1 into it again, but we'll get -1 to come out this time. So this is not a function. This example is the same way. We have 2 repeated. 2 is the repeated input. But for this 2, you get 2 come out. But for this 2, you get 3 come out. So this table is not a function either. Look at this third example. It is a graph. How can we tell whether it is a function or not from a graph? We are looking for vertical test. Another word, we put a vertical line here, and we see we have 2 different y's, but we only have 1 x here because every point on this vertical line have the same x. So it's 1 x, but with 2 different y's. We say this case failed the vertical test. It is a 1x mapped to 2 different y's. So this is not a function. Now look at the last example. This is a mapping diagram. It's very obviously, you can see this B mapped to 1 and mapped to 3 at the same time. We know 1 to many is not a function. So this is not a function. Now, you should all know how to judge whether it is a function or not. Simply speaking, you are looking for repeat x. If there is repeat x, then that's not a function. If you do not see repeat x, then it is a function. Thank you.